the safety manager of this project, and today I've been tasked with doing the pre-narration portion of the video. So, what we're going to be doing is, as a restaurant, we have to make sure that the food is adequate for both humans and Martians for consumption. And how we're going to make sure of that is we're going to measure both the temperature and set a timer based on the temperature, and have an alarm system go off when that timer is done. So how we're going to be doing that is we're going to be using the Arduino board, and we're going to have a PIR sensor and an LCD board attached to it. So the LCD board is going to display the countdown and a message corresponding with, the status of the food, basically when it's ready, when it's about to be ready, and when it's overcooked. So, yeah. And why we're doing that is obviously for food safety reasons, because you don't want something to be overcooked and you don't want something to be undercooked, because not only does it taste bad, it's also not safe for consumption.
Hi, it's Ayana, the media manager, and I'm going to be explaining everyone's roles for video 3. Bella and Karina are working on the coding, which you can see Bella's perspective on the left, and Karina's perspective in the middle. Daria and Darcy are both working on the schematics, which can be seen on the bottom right as well. But Gabby and I are both working on the document, post-recording, and I'm also working on video editing at the same time. Thank you, bye!
Hey guys, so we finally finished the code for the PIR system.
And we were able to set up all of the pins and the LCD on a separate breadboard. Here, we set it up on a separate breadboard, and we connected the red LED to a port separate from the green LED and the buzzer. Hi, my name is Bella, and I will be discussing the working demo. So first, our LCD prints waiting for food, indicating that there is no food. Then, once the food is placed on the grill, the PIR system detects it. The LCD prints food detected. The red LED turns on, and a timer for 10 seconds appears. Once the timer is up, the green LED turns on, and the LCD prints remove food, as well as the buzzer turning on for 1 second. Then it says waiting for food again, and the whole process starts over again.
Go!
Hi, my name is Bella, and I will be discussing the code portion of our assignment. So to begin, we first defined the pins for the LCD here, and they were all digital ports. And then we defined the pins for the PIR system, the 2 LEDs, and the buzzer. Next, I created a loop in which the LCD would print waiting for food initially, and once the PIR system detected food, right here, you can see in the code, once the PIR system detected the food, it would say food detected and have a countdown from 10 to 0 within another loop. That would delay every 1 second, so that way it was 10 seconds. Once the 10-second timer was done, it would print remove food, as well as turn on the green LED and turn on the buzzer. The buzzer would then play for 1 second. The red LED would turn off, which initially turned on when the PIR system first detected the food. And then it would delay for 3 seconds. Everything would turn off, including the buzzer, the LED, and the red LED. It would have enough time for the person to remove the food, and then the LCD would once again print waiting for food. And there's the ending code.
Okay, so here is our project. So first we started with the PIR sensor, which is right here. The PIR sensors, BCC was connected to the Arduino's 5V pin, and the ground was also connected to the Arduino's ground pin. And then the output was connected to the pin 7 on the Arduino. For the red LED, which is shown right here, it was connected to the pin 8 of the Arduino. Its anode was connected to the pin 8, and then the cathode, which is a shorter leg, was connected to a 220 ohm resistor, right there. And then for the green LED, The green LED was pinned to the number 9 on the Arduino. The buzzer, which is shown right here, which is what will create the sound of our project. The positive terminal was connected to the pin 10 of the Arduino. And then the negative terminal was connected to the ground pin of the Arduino. The LCD, which is shown right here, was connected to pin 12. The RS, the register select, was connected to Arduino 12. The EN, which was the enable, was connected to the pin 11. The 4 on the Arduino was connected to pin 5. The 5 connected to pin 4. The 6 connected to pin 3 of the Arduino. And then pin 7 was connected, D7, was connected to pin 2. And then the power supply, the VCC, the VSS of the pin of the LCD was connected to the ground, and then the VDD of the LCD was connected to the 5V pin on the Arduino, and the 5O pin could have been connected to a potentiometer, but we chose not to just because the potentiometer had a tendency of messing things up.
Hi, it's Ayana.
It's Gabby.
And we're reporting live from Martian Munchies. We're doing the post narration, and so I'm going to describe the difficulties we faced, which was there was no way of seeing the timer, which is the waiter's ability to know the exact time of cooking. There also was an issue with how to connect the alarm, timer, PIR, and LCD, with all of them not working as one. There was also an issue of not knowing exactly when the PIR was ready to sense the food. Because it's a motion sensor, it would sense when the food was being removed and reset before the new food was being placed.
So how did we resolve this? We tried using a timer, but that didn't work, so we went back to using LCDs like we did for the previous projects. It worked well. We just set it for 10 seconds and then it would display the time. Also, this was also working around the problem of beeping food warning alarms, and that's how we fixed it.
So what did we learn from this project? We learned how to effectively connect our components to have them all coordinate together. Additionally, we've learned more ways on how to use the alarm system and PIR system in general. Bye!
Bye!